Hello everyone, welcome back to emaTechTalk. Back here again is Sean and Matt. We just finished the virtual deep dive of technical features of the Smart Embedded Modem, EMA. Now let's look at a virtual tour and virtual deep dive of the dev kit emaPlay. Matt, take it away.
All right, thanks Sean. So let's get started. So I've got the emaPlay development kit shown on the screen here. Next to it is our Smart Embedded Modem EMA. And so let's just do just that. Let's take a virtual tour of the hardware. And so let's zoom in just a touch here. And the first thing that you'll notice obviously is the EMA modem sitting next to it on the right side. And one of the first things you'll want to do, if it's not already seated in the emaPlay kit when you get your development kit, is you'll want to take the EMA modem and place it in the socket. And really all you have to do is line the logos up, make sure the pins are lined up, and push it down in there. I'm not going to do that because I want it out to show some of the other components on here. And so we'll start in the top left corner and we'll work our way from there. If you look up here, there's a barrel connector for a DC power supply. And if you watched one of our other videos, we examined the contents of the emaPlay kit, and it does ship with a DC wall wart power supply. And the emaPlay kit accepts anywhere from 4.5 to 30 volts. And you can also power it from the wire to board terminal over here, where you can see where it says external VN. So if you have a bench power supply or a battery pack or something with wires that are hanging off of it, you can power it that way. And if we look closer at that blue wire to board terminal, you can also see that there's designators indicating RS-232, RS-485, EMA ring, and EMA status. And so the reason we have those on there is because the emaPlay development kit exposes the interfaces that are on the emaPlay 20-pin socket. And there's also built-in RS-232 translator and RS-485 and 422 drivers. And so you could theoretically run wires into this wire to board terminal or get the mating connector and plug it in here and have a machine or a piece of industrial equipment that talks Modbus or something to that effect, control EMA and have a cellular connection. And so let's move down here. There's another little switch right here. And that is also related. That's how you select whether or not you're going to use RS-485 or RS-232. Let me peel this antenna cable out of the way and let's move down here. If you see, there's 4 LEDs here, and basically what that does is it allows the demonstration project that ships in this kit to display the current signal strength or signal quality. There's also 2 LEDs over here, and these are red, and those can be used at will by the designer, or they can be used as part of the integration that we have that ships with emaPlay and the Banyan Hills Canopy IoT dashboard. There's a temperature sensor right there, temperature and relative humidity. There's a light sensor right there. Again, with the demonstration project that ships with the kit, all of these things are made use of, and you can examine the source code and see how they work. Over here is a 32-bit ARM Cortex M4 microcontroller that runs the demonstration project. There's a Segger J-Link on-board interface here for debugging and programming that microcontroller. There's also a standard ARM Cortex SWD interface if you want to use your own external programmer. Let's move over to this side. Right here is a manual switch to control turning EMA on and off and getting it connected on the network. When it's in the off position like it is right now, and these 2 dip switches are set how they are right now. It's kind of hard to see, but let me see if I can zoom up. You're basically telling the dev kit to allow the microcontroller to talk to Emma and use it, and that's how it's defaulted for the demonstration project. Now that doesn't mean that it has to stay that way. The dev kit is very robust, and through the use of adjusting these dev switches, you can direct Emma's modem AT interface as well as the Emma Link management interface to either the RS-485 or 232 interface that we talked about. You could also direct it up here to a serial to USB terminal and connect that to a Windows or a Linux environment. Or you can direct them to the I/O application header and interface with another external development kit. And so if you look in the center here, there's two push buttons that can also be used by the microcontroller for demoing other applications to test out your IoT or machine-to-machine application. And so let's take a closer look to the left side. We've got the U.FL to SMA antenna adapter cables, and that makes for an easy interface to our OptConnect Gemini antenna or any other antenna with the SMA interface. Underneath the modem, we expose the native USB interface such that if you wanted to use Emma with a Raspberry Pi, Windows, Linux, any higher level application or operating system, and you wanted to use the USB drivers, you would connect to this interface right here. You'll also notice there are some quick clip terminals around the board that can help you measure voltages and things like that. And so with that, I'd like to pass it back to Sean to close out this video.
Well, thanks, Matt. Appreciate the in-depth technical review of emaPlay. As you can see, you get a lot of things in that box that make it easy to develop your IoT application. emaPlay is just there. It can be used for your existing application as well as features for our new IoT solutions. So we're looking forward to a next episode, and thanks for joining us.